Welcome to this comprehensive video course about PostgreSQL, one of the world's most advanced and robust open source relational database systems. Whether you're a beginner looking to set up your first database or a seasoned developer aiming to scale and optimize complex data structures, this course has something valuable for you. Dive in as Alex unpacks the essentials, advanced features, and best practices to harness the full power of PostgreSQL in your applications.
Welcome to the exciting world of PostgreSQL. If you're like me and you're eager to unlock the power of one of the most robust and versatile relational database management systems in existence, you've come to the right place. In today's data-driven landscape, PostgreSQL stands as a pillar of reliability, scalability, and extensibility. Whether you're a seasoned database professional looking to enhance your skills, or, like me, a newcomer intrigued by the possibilities of managing and querying data efficiently, this course is our gateway to mastering PostgreSQL. Over the course of our program, we'll embark on a comprehensive journey through the fundamentals and advanced aspects of PostgreSQL. From setting up our first database to optimizing complex queries, we'll equip ourselves with the knowledge and practical skills needed to work with data effectively. I am dedicated to guide you every step of the way, ensuring that we not only grasp the core concepts, but also gain hands-on experience through practical exercises and real-world scenarios. By the end of this course, you'll be proficient in designing databases, leveraging PostgreSQL advanced features, and solving real-world challenges. Whether you're pursuing a career in data management, web development, or simply looking to boost our database expertise, PostgreSQL is a must-know technology. So join us on this educational journey and let's explore the dynamic world of PostgreSQL together. Get ready to unlock the potential of your data and open doors to a wide array of career opportunities. Hello everyone, welcome to the installation and setup lecture. In this video, we are going to install PostgreSQL and pgadmin. Now you may be wondering, what are those? Let's start with PostgreSQL, also known as Postgres, which is an open source relational database management system, RDBMS, that is known for its robustness, reliability, and advanced features. It provides a powerful and scalable platform for managing large volumes of structured data. PostgreSQL supports a wide range of data types, indexing options, and query optimization techniques, making it suitable for various applications. It offers ACAD, atomacy, consistency, isolation, and durability, compliance, and supports transactions, which ensure data integrity and reliability. With its extensibility and support for various programming languages, PostgreSQL is widely used in enterprise environments and by developers for building high-performance, data-driven applications. Now, what is pgadmin? pgadmin is a free open-source administration and development platform for managing PostgreSQL databases. It provides a graphical user interface that allows users to interact with the database and perform various administrative tasks. pgadmin offers a range of features, including database object management such as creating tables, views, and indexes, querying and editing data, monitoring database activity, and managing server settings. It provides a user-friendly environment for database administration and developers to efficiently work with PostgreSQL databases, allowing them to visually design database schemas, write SQL queries, and monitor database performance. pgadmin is available for multiple operating systems and is widely used as a primary tool for Postgres database administration. A shorter definition for what PostgreSQL and pgadmin is that PostgreSQL is the engine that stores data and reads queries and returns information, and the pgadmin is a graphical user interface for connecting with PostgreSQL. Note: please make sure to follow each step in order carefully. Common confusion points: do not open the DVD rental.tar file directly, and also another very important thing is to not forget the PostgreSQL password. So this is very important to have in mind. And to help avoid any missteps, I've numbered them and I will present them in the correct order for you. So let's get started. Step 1, let's download and install PostgreSQL. So open a browser and type PostgreSQL, press enter, and we need to go to this page where it says postgresql.org. Click on this link And this page may change from time to time, but the important thing here is to go to the downloading page, and we can go to the downloading page by clicking on this button or by clicking up here on download. I'm going to click up here on download. And here we have different versions for different operating systems like Linux, Mac OS, and Windows. I have Windows, so I'm going to select Windows for me. And down here we have PostgreSQL versions, and we have the versions for a 64-bit of Windows. And as you can see down here, there is also a version for a 32-bit version of Windows. So if you have a 32-bit version of Windows, you need to download this version that you see here. All right. Now I will go up and I will click download the installer. And I will go on the right hand side here, down here where it says Windows x86-64. I'm going to click on this button. And now PostgreSQL is going to be downloading, as you can see down here. And if you have a different browser, you'll see this in a different place. Alright, once the downloading is finished, just open this file. So I'm going to open this file. Let's close the browser because we don't need the browser anymore. And if the file didn't open for you, like in my case, just go to downloads or to the folder where you downloaded the file. Let's go to downloads. Let's double click on PostgreSQL. Now it's going to open. Click on yes. It's asking us if you allow this app to make changes to a device. Click on yes. Alright, here you have it, the installation window of PostgreSQL. And here we need to click on next. Here is the location where it's going to be installed. I'm going to click on next. I'm going to keep the default location. These are the software that are going to be installed with PostgreSQL. I'm going to keep the default selection, so click on next. Next we have the data directory, and here I'm going to keep the default directory, so I'm going to click on next. And now we need to create a password, and this is extremely important to not forget the password that we type here. So I'm going to type here password as the password. Click on next, and here we have the port, and this is the default, as you can see here, it's just 5432. Then I'm going to click on next here, and here you have select the locale to be used by the new database cluster. I'm going to keep the default locale. Click on next. I'm going to click on next again. Click on next again, and now PostgreSQL is going to be installed on my computer. Alright, once the installation is finished, just uncheck this stack builder because you don't need to open that, and click on finish. Now we're going to move to step 2, which is to download and install pgadmin. So I'm going to type pgadmin. We need to go here where it says pgadmin.org, click on this link. Let's click on agree. We go to download. And we're gonna select here Windows. If you have a different, you have some vendors here of Linux, and we have I'm gonna select Windows because I have Windows. So let's click on Windows. As you can see, there is also they no longer have version 3, but we're gonna use pgadmin 4. So click on Windows, and here we have different versions. I'm gonna click on this version for v7.4. So click on that. And here we need to download this executable file. So I'm going to click on this executable file. And now pgadmin is going to be downloaded on my computer. Once the downloading is finished, just open this file. Let's close the browser. Again, if it doesn't open the file for you, like in my case, go to the folder where you downloaded pgadmin, go to downloads, and we have here pgadmin. I'm gonna double click on it. I'm gonna click here, install for me only, recommended. I'm gonna click on next. I'm gonna accept the license agreement. I'm gonna click on next. And this is the location where it's gonna be installed. I'm gonna click on next. And now I'm gonna click here on next to install pgadmin. So click on next and install. Now the installation is finished. Let's click on finish. And let's move to step 3. Step 3, download, but do not directly open DVD rental.tar file. And DVD rental.tar file, it's a compressed version of a database that you're going to use throughout this course. And in downloads, if I go in downloads, I already have this file downloaded. As you can see here, we have DVD rental, so do not try to open that. And what I need you to do is to go to this particular video under resources, click on resources, and you'll see DVD rental file, and click on the file, and that file is going to be downloaded in our computer. This is what you need to do. And after that, step 4 is to restart your computer. So let's restart our computer. Step number 5, restore the database, and there is a quick note here, and that is to ignore the fail.exe code if it appears. And this can appear because it will think that you restore the database twice. So let's open pgadmin. So I'm going to type pgadmin. Let's click on run as administrator. It's asking us if you allow this app to make changes to a device. Click on yes. And it says starting pgadmin 4. Alright, it says loading pgadmin 4 v7 4, and this is not going to work. It will show this loading pgadmin indefinitely, and this happens because when we installed PostgreSQL, we also installed pgadmin 4, and after that I installed pgadmin again. And because of that, that generates an error, and it cannot open the pgadmin. So what we need to do is to go to control panel. So go to control panel, go to uninstall a program. Let's search for PostgreSQL. Let's click here. Let's uninstall it. And we are going to uninstall specifically pgadmin 4, because that is the problem, that is what generates the error. So let's select individual components, click on next, and make sure to check pgadmin 4 and click on next. Now we wait a little bit. Alright, the uninstallation is completed. Now let's close this. Let's type pgadmin, and let's run it as administrator. As you can see here, you can run it because you have it installed twice. So run it as administrator. Click on yes, because it's asking us if you allow this app to make changes to our device. It says starting pgadmin 4. And here you need to create a master password, and note that this password can be anything you want, and this is the password for the pgadmin, not for PostgreSQL. And I'm gonna type as the password, and then I'm gonna click on OK. Then on the left hand side we have servers, and I'm gonna click on servers. And now you see this pop up, and here you need to type the password that we created when we install PostgreSQL. So I'm gonna type here password and click on OK. And that is gonna open this. I already have here, actually I don't have the database. What I will need to do next is to right click here, go to create, actually above, create database. Let's call it DVD rental. Let's click on save. So now we have a database DVD rental. Now what we need to do here is right click and go to restore. And now we're going to reference our DVD rental .tar file. So I'm going to click here. And instead of custom files here, select all files. Go to downloads. And here we have DVD rental. Or you can copy this location directly from where it is in your PC and paste it here. And click on restore. And now it's going to restore the database, which is going to have some information. So, which is going to have some data that we're going to use to explain many things. So let's click on restore. And it says process started, restoring back on server PostgreSQL. And it says process completed. That means everything worked fine. Let's give it a refresh. So let's click on refresh. Now, the next very important thing is to right click here, go to query tool. And now that is going to open a window here. You can close those. And let's test our database. So I'm going to type here select. I'm going to look at all of those in more detail in the next videos. Asterisk from, and I'll type film. Semicolon. Again, I'm going to explain all of this in the next videos. And click on this run button. And now I have data being outputted down here, as you can see. So everything works fine. Welcome back. Now it's time to start a discussion about the select statement. So what is the select statement? The select statement is used to retrieve data from one or more database tables. It allows you to specify the columns you want to retrieve, the tables from which you want to retrieve the data, and any conditions that must be met for the data to be included in the result set. Later, we'll learn how to combine select statement with other SQL select statements to perform more complex queries. Here is how the syntax of select statement looks like. So we have select, then we have the column name, then we have the keyword from, and the table name. And now this is how this will look. Let's say that we have a few tables, which are, I created here a few tables which are populated with data, and let's say that you want to retrieve some data from those tables. Based on what I told you, what you need to do here is to type select first, but first of all you need to think about from what table you want to retrieve the data. So the table name, let's say that I want to retrieve that data from the table 1. So with that in mind, you type the select keyword, the column name, let's say C1, and it will retrieve all the data in the column C1 from the table 1. So in this way you will get all the data for the column 1, C1, from the table 1. Now let's say that you want to retrieve 2 columns. You can do that by putting commas. So you can type again select, you type the column name, let's say C1, comma, and C2, and that now it will return back all the data from the column 1 and column 2, from the C1 and C2. Let's say that you want to retrieve data from a different table. In order to do that, you again type select, let's say C1 and C2 again. We get the data for those columns, and now we change the table name. We type, let's say, table 3. Now, let's say that you want to retrieve all the data from a table. Of course that you can type select, and you type the column name C1, C2, and C3 from the table name. But what if you have hundreds or thousands of tables. In that way, because of that, it will not be practically possible to type all of that. And in order to get the data from all the columns, you need to type select asterisk from and the table name, table 1. And that is going to return all the data from the table 1, all the columns. So this is what it will do. Now, one more thing. The select keyword is used to specify, as I said, the columns you want to retrieve, and you can specify individual column names separated by commas, as I said, or you can use an asterisk to select all the columns from the specified tables. But in practice, it's better not to use the asterisk when you don't need to use the asterisk, because it will get a lot of data and it will make the communication between the database and the software that you're using slower. All right, now let's move to PostgreSQL and let's type some select statements. All right, so I'm going to open pgadmin, run as administrator, click on yes. We wait a little bit until pgadmin starts. Right, pgadmin opened. Let's click on here on this greater arrow in front of servers. Now it's asking us for the password. Let's type password. And let's click here to save password to not type it again every time we open the server. Now it's going to open the server. We have our database here. I'm going to click there and have DVD rental, the database that we created, and Postgres, the database that was provided implicitly for us. Now, let's say that I want to query, and I want to query. So I'm going to right click on the database that I want to query, go to query tool. And that is going to open the query window. Right, and now here I can type a statement. But first, before I do that, let's go to schemas to see how the structure of our database looks. So click on schemas. Go to, let me see, tables, to see what tables we have. And as you can see here, we have the tables actor, address, category, city, country, and so on. Now, let's say that I want to select all the columns from the table actor. I'm going to type select with capitalized letters from actor, semicolon. Now let's run this. Now it's returning all the actors so it's returning all the actors from the table actor. Now let's say that I want to get only the first name and the last name. In order to do that, I'm gonna delete this. I'm gonna type, and to see what kind of structure the table has, you can right click in front of it and you'll see what columns it has. It has actor ID, first name and last name. So let's type first name, first underscore name, comma, and let's actually only ask for the first name from, so you don't put the asterisk, actor, semicolon. Let's increase this. Let's click on run. And we get all the first names of all the actors in our table actor, as you can see down here in the data output. So everything works fine. And you can put a comma here, and you can get the last name too. So we type last name, because as you can see, it also has a last name. And if you run this, all right. Oh, I should put a comma there. Let's run it again. So you have the first name, as you can see here, and the last name. So now it's returning the first name and the last name. And they don't need to be in this order. So then the first name doesn't have to be before the last name. I can type here last name, comma, first name. Now if I click on run, this will still work. So everything is working the same. Now, as you see here, the SQL keywords are capitalized, but you can type them in lowercase letters and it will still work. But it's a good convention to capitalize them to make sure that you can see the distinction between the SQL statements and the column names, right? So always capitalize the SQL keywords, if you want to call it like that. All right, so this is our discussion for this video. I hope that you enjoyed, and see you in the next video. Welcome back. In this video, we are going to do a challenge with the select statement. And here is how the challenge structure is going to look like. First, we're going to have a business situation, because often when working with SQLite databases, you'll have a business situation and you need to translate to get that business situation and to translate it into a query. So this is what we will do first. We will see the business situation. Then we have the challenge question, and this is more about SQL, and here we're going to ask the actual challenge, the actual question. Next, we have the expected answer, and here I'm going to show you what the expected answer is going to look like. Next, we have the hints, so I'm going to give you some hints about the challenge, so it will be easier for you to solve. And finally, I'm going to show the solution. So let's start with the first one, the situation. So what we want to see is the payment date of our existing customers. So this is the situation. Next, we have the challenge. You need to use the select statement to grab the customer ID of every customer and the payment date and the payment date and the amount. So you need to do this. This is the challenge. And if you already know how to use this, how to solve this challenge, you can jump in and try to identify the table from which you can get this data and run the query statement. So this is what you're gonna do. And now I'm gonna show you the expected answers, and this is very important. This might not be displayed in the exact same order, because how SQL works is that it tries to return the data in the most efficient way, but later you will see how you can actually control how the data is ordered. But we're gonna look at that in the next videos. Now we're not gonna do that here. And next we have the hints. So the hint is to use the payment table, and you can use the table to drop down to view what columns are available. So this is what you could do. Next we have the solution, and the solution is, let's open pgadmin. So let's open pgadmin. So let's open pgadmin. Let's run it as an administrator. Click on yes. Now pgadmin is going to start. Alright, so pgadmin started. Let's open our server And now it's not asking us for the password because previously we saved the password. And let's open the query tool because we're gonna type a query. And if you figure out how to solve this challenge, write me in the comment. The thing that you need to do is to go to payment, because here we're gonna have our columns. I'm gonna click on this greater arrow in front of columns, and here we have customer ID, amount, and the payment date. So in the challenge I said that you need to get, so I'm gonna type select, and I'll type customer ID, comma, amount, comma, and payment date, from, and the name of the table, which is payment. And I'll put a semicolon to indicate that this is the end of the query, but this can work also without the semicolon. But I'm going to put semicolon, and let's run our query. And we have the customer ID, we have, as you can see, customer ID, the amount, and the payment date. So everything works fine. I hope that you figure out how to solve this challenge, and see you in the next video. Welcome back. Now it's time to start a discussion about the select distinct statement in SQL. So in SQL, the distinct statement is used to filter the result set of a query and retrieve only unique rows from the specified column or combination of columns. It is particularly useful when you want to eliminate duplicate records from the query results. So this is what the distinct statement is going to do. Now, the syntax for using the distinct statement is straightforward. You simply place the keyword distinct immediately after the select clause, followed by the column name or names for which you want to retrieve the distinct values. Here is the basic syntax. You have select, distinct, column, from, and the table name. So this is the syntax of the distinct statement. Now, if you want to clarify which column the distinct is being applied to, we can also use parentheses for that. So you can type select, distinct, parentheses, the name of the column, from, and the table name. In this way, you'll make it more clear what data you want to retrieve. Now, let's break down how the distinct statement works. First, the SQL query is executed as usual, fetching the data from the specified table or tables. Secondly, the query engine then removes any duplicate rows from the result set based on the columns specified after the distinct keyword. And third, only the first occurrence of each unique combination of values in the specified columns is returned in the result set. So we will not have duplicates. Now, let's consider this table called employees with the following data. So we have the employee ID, the first name, last name, and the department. And as you can see in this table, the John is present twice. So we have John Smith, and we have also the same department. Now, this can be a duplicate, but it can also not be a duplicate. Maybe there are two persons with the same name working in the same department. So what the distinct keyword is gonna do is it will answer to the question, what are the unique first names in the table? Let's say that you want to retrieve the first name and the last name. So if you use the distinct keyword, it will answer to the question, what are the unique first name and last names in the table? So this is what it is doing. And so as I said, given this example, we don't really know if the person with the same name, John, was a duplicate entry or two different people with the same first name, last name, and department. So again, the distinct returns only the unique entries. So this is what distinct is doing. Now, if you run the following query, so you type select distinct first name, last name from employees, this will be the result. You have the first name John, last name Smith, you have Jane Doe, then you have first name for the Alice and Johnson. So this will be the the result if you use the distinct statement. Alright, now let's move to PostgreSQL to work with distinct statement. So let's open pgadmin, run it as administrator. Now pgadmin will start in a short moment. Alright, let's open the server. Let's open the query tool. Query tool. And I'll type here select. So I'm gonna select all from the film table. And you can see the film table down here. So let's click on run. As you can see, you have the film ID, the title and description, and if you go to the right, you also have the release here, language, ID, rental duration, all of this. Rental rate, length, all of those columns. And if you want, you can watch what columns the film has here, simply by clicking on this greater arrow here in front of columns, and you'll see all the columns here. Now let's say that I want to select the release year. So I want to see what are the unique release years for all of our movies. I can type, let's delete also that. I can type here distinct release, just to make sure it's the same as the table name, year from film. Now if you run this, alright, so I typed this wrongly. Let me see how it's release. Without the A here. Let's run it again. And we have only 2006, only one occurrence of this of the year. So we have only one occurrence, so one unique year in which all the movies were published. Now we can also put parentheses. So we can put parentheses around this. And I can run this and I will get the same output. Right, let's also see how we can get the rental rate. So release distinct, let's delete that. Let's type here select distinct from, let's type, but let's type again select all from film, because I want to see the columns. So let's type again, let's run it, let's go to the right, and we have rental rate. So let's type here, let's delete this, let's type select. So we're gonna see what how many unique rental rates we have for this film. Rental underscore rate from film. Let's run this, and we have all of those that you can see here. So those are the unique rental rates. That, oh sorry, I forgot to put distinct, because here we have as you can see duplicates. So let's type distinct, dummy me. So let's type distinct, let's run it. Alright, so now it returns the correct result. So we have this unique rental rate, this one, and this one. We have three unique rental rates for our movies. Alright, I'm gonna end this video here and see you in the next video. Welcome to the select distinct challenge. In this challenge, we're gonna follow the same structure as previously. So we're gonna have first the situation, then I'm gonna have the SQL challenge, the expected results, then I'm gonna give you some hints, and finally we're gonna have the solution. So let's start with the situation. Let's say that you are a data analyst working for some video rental store, and the management has noticed that some customers have similar names, and they wanted to identify the unique first names across all customers in the database. So this is the situation that we're given. The SQL challenge is to write a SQL query to retrieve all distinct first names of customers from the customer table. So this is the challenge that we need to do. Now, the expected results. Your SQL query should result in a list of unique first names from the customer table, like you can see in this example, without any specific sorting. And the hints. We have the hints. Use the select statement along with the distinct keyword to retrieve unique values. And to select distinct values from a specific column, simply specify that column after the distinct keyword in the select clause. So those are the hints. And the solution is this: select distinct first name from customer. So this is the solution to our challenge. And in this challenge, we use the select statement with the distinct keyword to retrieve all unique first names from the customer table. The query returns a list of distinct first names without any particular sorting, allowing the database to return the results in its natural order. The database may return the results in the order they were inserted or in any other internal order. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the count function. But first, let's go through each aspect of the count function in SQL step by step using some simple tables to grasp the information better. So, the count function in SQL. The count function in SQL is an aggregate function that allows you to count the number of rows that match a specified condition within a table or a result set. It returns a single value representing the count of rows that meet the criteria. So this is what the count function is. Why is count function useful? The count function is valuable for various data analysis tasks. It helps you to obtain statistical information about your data, such as counting the number of records in a table, calculating the occurrence of a specific values in a column, finding the number of rows that met certain conditions, determining the number of unique values in a column when used with the distinct statement. So this is why count function is useful for these reasons. When to use the count function? You should use the count function when you need to determine the size of a table, the number of rows it contains, count occurrences of specific values in a column, get the summary statistic about your data. So this is where you should use the count function. How to use the count function with the distinct statement? The distinct keyword is used to eliminate duplicate rows from the result set. When combined with count function, it allows you to count the number of unique values in a specific column. Here is how we can use it. Let's consider a simple table called employees. As you can see here, you have this table, you have the employee ID, the employee name, the department, and as you can see in this table, we have 5 rows and you have multiple departments, but you have duplicate departments. As you can see here, you have the human resources twice and the IT also, you have it twice. Now, let's say that I want to count the number of employees in the table. If I do that, the count is going to return 5. And it's going to return 5 because we have 5 rows. So this is what that will return. Now, example 2. Let's count the number of unique departments in the employee table using distinct keyword. So we're going to type select count parenthesis distinct department from employees. And when you're going to do that, the result is going to be 1 because we have human resource, 2 for finance, and 3 for IT. So we have 3 unique departments in our department table, on our department row. So this is how you can use that. And let's wait. In this example, we use the count function with the distinct statement to count the unique departments in the employee table. It returned the count as 3 because there are 3 unique departments: human resources, IT, and finance. I hope that this example helped to illustrate the usage and usefulness of the count function in SQL, particularly when combined with distinct statement. It allows you to perform various data analysis tasks and retrieve valuable information from your database. Alright, now let's move to PostgreSQL to type some code. But before you open pgadmin, let me first explain what is the difference between count with asterisk and count without asterisk, so count with the column name. And in SQL, the usage of count function with and without asterisk depends on what you want to count. Let's explore the differences and when to use each form. Count with parentheses and asterisks. When you use count with parentheses and asterisks, it counts all the rows in the specified table, regardless of the values in the columns. Here is the syntax. We have select, count, parentheses, asterisk, from, and the table name. Now, let's see the usage. Use count with parentheses and asterisks when you want to count the total number of rows in a table, irrespective of whether there are null values or not. It counts all rows, including those with null values in any column. So, this is what count with asterisk does. Let's consider an example. Let's say that we have a table a table called students, and we have the student ID, student name, and age. And as you can see, for the student name, we have here a null value, so it didn't provide a name. Now, that is because by using count with asterisks, it will count even if you count it. So let's say that you want to count the total number of student names. It will count also the null one if you use count with asterisks. Count without asterisks. So when to use count with the column name. So you specify a column name inside the parentheses of the count, and it counts the number of non-null values in that particular column. Here is the syntax. So this is different. This only counts the number of non-null values. Usage. You use count with column name when you want to count the occurrence of non-null values in a specific column. It ignores null values in the column and only counts non-null entries. Example. And continuing with the students table, let me show you. Let's wait a little bit. If you type select count, let's make this, so let me change something here. If you type select count, the student name in parentheses, from students, the count is gonna return 4 because the count without asterisk is returning all the non-null values. So because the student name 5 with the ID 5 is null, it's not going to count, it's going to return 4. So this is what count with the column name is doing. Alright, let's move to the next. Now, in this query, count student name only counts the non-null values in the student name column, excluding the row with null name. Hence, it returns the count of 4. When to use each form? Use count without asterisk when you want to count all rows with asterisk, including those with null values, or when you don't have a specific column to count, but you still need to retrieve the total number of rows in the table. Use count column name when you want to count the occurrences of non-null values in a particular column, ignoring null entries. This is useful when you want to analyze the distribution of frequency of non-null values in a specific attribute. In summary, the decision to use the count without or without asterisk depends on whatever you want to count all rows, including nulls, or you want to count only the occurrences of non-null values in a specific column. and you can choose the appropriate form based on your analysis needs. Alright, let's move to the next slide. In summary, count with asterisk counts all rows in the table, including rows with null values in any column, and count with column name counts the number of non-null values in the specified column, ignoring rows with null values in that column. Choose the appropriate form of the count function based on your specific requirements. If you want to count all the rows in the table, regardless of the null values, use count with asterisk. If you want to count the number of non-null values in a specified column, use count with the column name. Alright, now let's open pgadmin. Alright, let's open pgadmin now. Let's run it as administrator. Let's open the server. Let's open the query tool. And I'll type here. Let's say that I want to get all the data from the payment table. I will type select from payment, semicolon. Let's run this. Right, now let's say that I want to know the number of rows in this table. What I can do is I can type here select count asterisk, I'm gonna put parentheses, asterisk, so parentheses again, asterisk from payment, and that is going to return the number of rows. Let's click on the run, and we have 40,596. Now you can do another way. I can type here amount, the name of a table, not the name of the name of let me open this, of a column, and that is going to return the same result. As you can see here, everything works fine. Now next, let's say that I want to retrieve the actual number of the unique amounts. So I'm going to type here select distinct amount from payment. So if you run this, we get our distinct amounts. Now let's say that I want to get the number of those distinct amounts. How I'm gonna do that? This part is gonna return the number of distinct amounts. So we need to put here before count. So I'm gonna type here count, parentheses. We put our distinct inside the parentheses, distinct amount, because that is going to return the distinct amount of payments. And now if you run this, you get 19. And you can also put this in parentheses to make it more clear. Another parenthesis here. Now if you run this, you get also 19. So this returns the number of unique amounts in our payment, and the count is counting them. So I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the select where statement in SQL. So in SQL, where statement is a crucial part of querying and filtering data in a relational database. It allows you to retrieve specific rows from a table that match certain conditions. In this detailed step-by-step explanation, I will cover everything you need to know about the SQL where statement. Basic syntax. The where clause is typically used in combination with the select statement to filter rows based on specific conditions. The basic syntax is as follows: select the name of the column or the name of the columns, from the name of the table, where, and then you pass the condition. Next, select. It specifies the columns you want to retrieve from the table. From indicates the name of the table that you are querying. Where introduces the condition that filters the rows. The condition is evaluated for each row in the table, and only the rows that met the condition will be included in the result set. So it's very important to have this in mind. And now you may be wondering, what is a condition? A condition is a logical expression that evaluates to true or false in SQLite for each row in the table. The where clause uses those conditions to determine which rows to include in the result set. Common operators using conditions include equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to, between, a range of values, inclusive, and we have like for pattern matching, in for which matches any value in a list. You have is null, and, or not, which are logical operators, and we're going to look at all of those in the next minutes. Next, let's look at each operator step by step. So let's start with the equal to operator. The equal to operator checks whether two values are exactly equal. It is used to filter rows where the specified column is equal to a given value. Example, we have select from employees where department equals sales. This query will retrieve all employees from the employees tables whose department is sales. Next, we have the not equal to operator. And the not equal to operator checks whether two values are not equal. It is used to filter rows where the specified column is not equal to a given value. Example, we have select from employees where department is not equal to finance. This query will retrieve all employees from the employees table whose department is not finance. Next, we have the greater than operator. The greater than operator checks if the left-hand side value is greater than the right-hand side value. It is used to filter rows where the specified column is greater than a given value. Example, and we have select from employees where age is greater than 30. This query will retrieve all employees from the employees tables whose age is greater than 30. Next, we have less than operator, and the less than operator checks to see if the left-hand side value is less than the right-hand side value. It is used to filter rows where the specified column is less than a given value. Example, we have select from employees where salary is less than 500,000. This query will retrieve all employees from the employees table whose salary is less than 50,000. So next, we have greater than or equal to operator. And the greater than or equal to operator checks to see if the left-hand side value is greater than or equal to the right-hand side value. It is used to filter rows where the specified column is greater than or equal to a given value. So it have example, select from employees where experience is greater than 5. This query will retrieve all of the employees from the employees tables whose experience is greater or equal to 5 years. Less than or equal to operator. The less than or equal to operator checks to see if the left-hand side value is less than or equal to the right-hand side value. It is used to filter rows where the specified column is less than or equal to a given value. Example, we have select from employees where rating is less than or equal to 4.5. This query will retrieve all employees from the employees table whose rating is less than or equal to 4.5. The between operator. The between operator checks if a value lies within a specified range, inclusive. It is used to filter rows where the specified column value is within a range. Example, we have select from employees where age between 20 and 40. This query will retrieve all employees from the employees table whose age is between 20 and 40 inclusive. And this is very important, inclusive. Like operator. The like operator is used for pattern matching with wildcard characters like %sign or underscore, where %sign represents 0, 1 or multiple characters. while underscore represents a single character. Example, we have select from, so select asterisk from employees where first name, like, and you put in a single quotation mark, J, and percentage sign. This query will retrieve all employees from the employees table whose first name starts with the letter J. The in operator. The in operator checks if a value matches any value in a list of a specified values. It is used to filter rows where the specified column's value is one of the given values. So we have, for example, select asterisk from employees where department in human resource, finance, or admin. And this query will retrieve all employees from the employees tables whose department is either human resource, finance, or admin. Next, we have the is null operator, and the is null operator checks if a value is null, no value. It is used to filter rows where the specified column value is null. Example, select asterisk from employees where phone number is null. This query will retrieve all employees from the employees tables who have not provided a phone number, where the phone number is null. Logical and the logical or operator. The logical operators and or are used to combine multiple conditions in the where clause, and requires all conditions to be true for a row to be included, while or requires at least one condition to be true. Example, we have select asterisk for employees where department equals human resource and age is greater than 30. This query will retrieve all employees from the employees table whose department is human resource and the age is 30 or older. So next we have select from employees where department equals finance or department equals marketing. This query will retrieve all employees from the employees table whose department is either finance or marketing. So these are all the operators that you can use in SQL. I'm gonna end this video here and see you in the next video. Alright, so now let's open pgadmin and let's code some examples using the select where statement. So let's open pgadmin. I'm gonna run it as an administrator. Now pgadmin is gonna start. We wait a little bit until it's starting. Alright, so pgadmin started. Let's increase this window. Let's go to servers. We have PostgreSQL, we have our DVD rental, and let's right click. Let's go to query tool. And we have the customer table here, and let's say that I want to get all the data from the customer. So let's get all the data from the customer table from customer semicolon. Now if you run this, as you can see, have customer ID, store ID, first name, last name, email, have address ID, an active boolean if the user is active or not, created date, last update, and active, and have 1 and zeros if it's not active. Now let's say that I want to filter the results. What I can do is I can remove the semicolon and I can type here select from customer where first name. Let's say that I want to get from the store the person with the first name called Mary. You're gonna put equals single quotation marks. I'm gonna type Mary. So now if I, and you can put this on the next line if you want. So I can type it like this if I want. So let me push it back. Now let's run it. We can put semicolon here if you want. It will still work without semicolon. And we have As you can see, the first name Mary and the last name Smith, and we have the email, address ID, the active boolean, and so on. So let's now explore the field table to show you how what else we can do with these where statements, because we're gonna look also at the logical. We're gonna look at how we can combine condition with the logical and on logical where operator. So let's change this. Select from film. So let's increase this. Let's see the columns of the film, and let's run it. And we have title, description, we have release year, language, rental duration, rental rate. Let's say that I want to get from this film where, so where rental rate, so rental rate is greater than 4, semicolon. Now if you run this, oh, it should be a rental. Let's run it again. And now we're going to get all the fields where the rental rate is greater than 4. As you can see here, we have 499, 499, 499. Now, if I want to add more conditions, here I can use the logical AND operator. So I can type where rental rate is greater than 4, and I can type here replacement. Let's say that I want to filter to see the ones which have a higher price for the replacement, for the replacement cost. So I'm going to type replacement cost. Make sure that you type that correctly. Is greater than equal to 99, semicolon, if you want. Let's run this. And if you go on the right here, you're gonna see that we have all which have the replacement cost bigger than 19.99. So everything works fine. This is how it's filtering our results. Now I can chain another condition here using the AND operator, and I don't need to type this where again, because it will be applied to all the condition which I stick them together with the AND operator. So I can type on the next line AND, another AND. Let's say that I want to get from film where the rental rate is greater than 4, the replacement cost is greater than 19.99, and let's say that I want to get all the movies which have the rating R. So I'm gonna type rating R, single quotation marks, R, semicolon. Now let's run this, but first let me show you that now we have those which also don't have R because they don't have that condition. Let me see where it is. Alright, so as you can see, you have NC17, you have PG, you have PG13, but now if I run this, if I go on the right, now I'm gonna have only the movies which have the R rating, as you can see here. So only those movies are returned back. So this condition, this entire with where is gonna return all the results for which this condition that we define, those conditions that are defined here are true. So for all of them. All right. So this is what we can do. Now let's say that I want to get. So let's say that I want to count how many movies are with the rating R. So how many movies are, let's say, which match this particular condition. So I want to get all the movies, so all the films for which this condition is true. So I want to see how many there are. So let's run this, and we get 34. So there are 34 movies which are rating as R, have the rental rate greater than 4, and the replacement cost greater than 19.99, and also which has again, when I repeat myself here, rating is where the rating is R. And you can also put here, if you want, title. It will still work because it will return 34 rows. All right. So this is how you can use the count. Now let's see how you can use the logical OR operator. So let's say that I want to get select, let's say Let's type here title from film where. Let me actually type select from film again because I want to see the columns from. So select from film because I want to see all the columns. Let's run it. And let's say that I want to get the ones which have the rating R in PG or the rating PG-13. So I can type here where rating equals to R, and now I'm going to type the logical OR operator, or rating equals to PG-13. So let's run this. And notice that I don't add the semicolon, it still works if you don't add the semicolon. And now I have all the movies which have the rating either R or PG-13. And you can also use count here. Count all the columns. So I'm going to put count, if you know this from the previous videos, to see how many movies are which have the rating R and or PG-13. So if you run this, you get 418. Alright. So this is our discussion for this video, and see you in the next video. Now it's time to do a challenge using the select where statement. And in this video, like in the previous videos, we're going to have the same structure. So we're going to have first the business situation, the expected result, the hints, and finally we're going to have the solution. So let's start with our first challenge. So challenge number 1. Let's say that you're running a DVD rental store and want to find the titles of films which are released in or after the year 2000 that have a rating of PG-13. And you also need to know the replacement cost of those films. So let's see the expected result. So this is what you will see in the expected result. Retrieve all the titles and replacement cost of films that were released in or after the year 2000 and have a rating of PG-13. So this is what you should see after running that particular query. Now let's look at hints. You need to filter the films based on their release year and rating. And the rating column stores the film's rating. The release year column stores the year a film was released. So those are the hints. And now let me show you the solution. The solution is to type select title replacement cost from film where release year is greater than or equal to 1000 and, so the end operator, rating equals to PG-13. So this is the solution. Now let's move to challenge number 2. Let's say that you want to see the titles of films which have a rating of PG and the replacement cost of $10.99. So let's see the expected result. So the expected result is going to retrieve the titles of films that have a rating of PG and the replacement cost of 10. I repeat, and the replacement cost of $10.99. So this is going to be the expected result. This is what you should see in the output. Alright, now let me show you the solution. Not the solution, let me give you the hints. You need to filter films based on the rating and replacement cost first. The rating column stores the film's rating, and the replacement cost column represents the cost to replace a film. So these are the hints to solve this challenge. Now the solution. The solution is to select title from film where rating is PG and replacement cost equals $10.99. And that is gonna solve our challenge. Now let's move at challenge number 3. Challenge 3 is you want to find the titles of films released either before the year 2000 or with a replacement cost less than 10. So you either now let's look at the expected result. And the expected result is going to retrieve the titles of films that were released before the year 2000 or have a replacement cost less than $10. So this is what we're going to see in the output. Now let's see the solution. So let's see the hints. So you need to filter films based on their release year and replacement cost. The release year column stores the year a film was released, and the replacement cost column represents the cost of to replace a film. So those are the hints. Now let's see the solution. The solution is to type select title from film where release year is less than 2000 or replacement cost is less than 10. So I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the count function. But first, let's go through each aspect of the count function in SQL step by step using some simple tables to grasp the information better. So, the count function in SQL. The count function in SQL is an aggregate function that allows you to count the number of rows that match a specified condition within a table or a result set. It returns a single value representing the count of rows that meet the criteria. So this is what the count function is. Why is count function useful? The count function is valuable for various data analysis tasks. It helps you to obtain statistical information about your data, such as counting the number of records in a table, calculating the occurrence of a specific values in a column, finding the number of rows that met certain conditions, determining the number of unique values in a column when used with the distinct statement. So this is why count function is useful for these reasons. When to use the count function? You should use the count function when you need to determine the size of a table, the number of rows it contains, count occurrences of specific values in a column, get the summary statistic about your data. So this is where you should use the count function. How to use the count function with the distinct statement? The distinct keyword is used to eliminate duplicate rows from the result set. When combined with count function, it allows you to count the number of unique values in a specific column. Here is how we can use it. Let's consider a simple table called employees. As you can see here, you have this table, you have the employee ID, the employee name, the department, and as you can see in this table, we have 5 rows, and you have multiple departments, but you have duplicated departments. As you can see here, you have the human resources twice, and the IT also, you have it twice. Now, let's say that I want to count the number of employees in the table. If I do that, the count is going to return 5. And it's going to return 5 because you have 5 rows. So this is what that will return. Now, example 2. Let's count the number of unique departments in the employee table using distinct keyword. So we're going to type select count parenthesis distinct department from employees. And when you're going to do that, the result is going to be 1 because we have human resource, 2 for finance, and 3 for IT. So we have 3 unique departments in our department table, on our department row. So this is how you can use that. And let's wait. In this example, we use the count function with the distinct statement to count the unique departments in the employee table. It returned the count as 3 because there are 3 unique departments: human resources, IT, and finance. I hope that this example helped to illustrate the usage and usefulness of the count function in SQL, particularly when combined with distinct statement. It allows you to perform various data analysis tasks and retrieve valuable information from your database. Alright, now let's move to PostgreSQL to type some code. But before you open pgadmin, let me first explain what is the difference between count with asterisk and count without asterisk, so count with the column name. And in SQL, the usage of count function with and without asterisk depends on what you want to count. Let's explore the differences and when to use each form. Count with parentheses and asterisks. When you use count with parentheses and asterisks, it counts all the rows in the specified table, regardless of the values in the columns. Here is the syntax. We have select, count, parentheses, asterisk, from, and the table name. Now, let's see the usage. Use count with parentheses and asterisks when you want to count the total number of rows in a table, irrespective of whether there are null values or not. It counts all rows, including those with null values in any column. So this is what count with asterisk does. Let's consider an example. Let's say that we have a table for a table called students, and we have the student ID, student name, and age. And as you can see, for the student name, we have here a null value, so it didn't provide a name. Now, that is because by using count with asterisks, it will count even if you count it. So let's say that you want to count the total number of student names. It will count also the null one if you use count with asterisks. Count without asterisks. So when to use count with the column name. So you specify a column name inside the parentheses of the count, and it counts the number of non-null values in that particular column. Here is the syntax. So this is different. This only counts the number of non-null values. Usage. You use count with column name when you want to count the occurrence of non-null values in a specific column. It ignores null values in the column and only counts non-null entries. Example. And continuing with the students table, let me show you. Let's wait a little bit. If you type select count, let's make this. So let me change something here. If you type select count, the student name in parentheses from students, the count is gonna return 4 because the count without asterisks is returning all the non-null values. So because the student name 5 with the ID 5 is null, it's not going to count, it's going to return 4. So this is what count with the column name is doing. All right, let's move to the next. Now, in this query, count student name only counts the non-null values in the student name column, excluding the row with null name. Hence, it returns the count of 4. When to use each form? Use count without asterisks when you want to count all rows with asterisks, including those with null values, or when you don't have a specific column to count, but you still need to retrieve the total number of rows in the table. Use count column name when you want to count the occurrences of non-null values in a particular column, ignoring null entries. This is useful when you want to analyze the distribution of frequency of non-null values in a specific attribute. In summary, the decision to use the count without or without asterisk depends on whatever you want to count all rows, including nulls, or you want to count only the occurrences of non-null values in a specific column. And you can choose the appropriate form based on your analysis needs. Alright, let's move to the next slide. In summary, count with asterisk counts all rows in the table, including rows with null values in any column, and count with column name counts the number of non-null values in the specified column, ignoring rows with null values in that column. Choose the appropriate form of the count function based on your specific requirements. If you want to count all the rows in the table, regardless of the null values, use count with asterisk. If you want to count the number of non-null values in a specified column, use count with the column name. Alright, now let's open pgadmin. Alright, let's open pgadmin now. Let's run it as administrator. Let's open the server. Let's open the query tool. And I'll type here. Let's say that I want to get all the data from the payment table. I will type select from payment, semicolon. Let's run this. Right, now let's say that I want to know the number of rows in this table. What I can do is I can type here select count asterisk, I'm going to put parentheses, asterisk, so parentheses again, asterisk from payment, and that is going to return the number of rows. Let's click on the run, and we have 40,596. Now you can do another way. I can type here amount, the name of a table, not the name of the name of let me open this, of a column, and that is going to return the same result. As you can see here, everything works fine. Now next, let's say that I want to retrieve the actual number of the unique amounts. So I'm going to type here select distinct amount from payment. So if you run this, we get our distinct amounts. Now let's say that I want to get the number of those distinct amounts. How I'm going to do that? This part is going to return the number of distinct amounts. So we need to put here before count. So I'm going to type here count, parentheses, we put our distinct inside the parentheses, distinct amount, because that is going to return the distinct amount of payments. And now if you run this, you get 19. And you can also put this in parentheses to make it more clear. Another parenthesis here. Now if you run this, you get also 19. So this returns the number of unique amounts in our payment, and the count is counting them. So I'm going to end this video here and see you in the next video. Now it's time to start a discussion about the order by clause. So the order by clause in PostgreSQL is used to sort the result set of a query in a specified order. It is used when you want the query's output to be presented in a particular sequence based on one or more columns values. This can be crucial for making query results more meaningful and easier to interpret. Now, why do you need to use the order by? First, we have data presentation. So when displaying query results to user, it is often important to have data presented in a logical and readable order. For example, if you're displaying a list of products, you might want to show them in ascending or descending order of price. Second, we have analysis. In cases where we're performing data analysis, sorting the results can help you identify trends, outliers, or patterns more easily. For instance, when analyzing sales data, sorting by the date help identify sales patterns over time. Next, we have pagination. So pagination is when dealing with large data sets. You might want to implement pagination to show only a subset of data on each page. Proper sorting is essential to ensure data consistency between pages. So this is pagination. Now, usage of order by. The syntax of the order by clause is as follows. We have select, we have the column or the columns, from, where, you can put a condition if you want, and we type order by, and we sort by a column, and we define the order of being ascending or descending. And you can also use two columns if you want. So this is the syntax of the order by. Now, here is what each component does. So select specifies the columns you want to retrieve from the table. From specifies the table from which you're retrieving data. Where it's an optional condition to filter the rows before sorting. Order by specify the columns by which the result set should be sorted. You can sort by one or more columns, and for each column you can specify ascending, which is the default, or descending order. So now let's look at an example in pgadmin. Now let's work with some examples in pgadmin, and for this purpose I'm going to use the customer table. I'm going to select everything from the customer table. So I'm going to type select from customer and the optional semicolon. Let's run this, and you see in the data output we have the customer ID, store ID, first name, last name, email address, and active boolean created. So but now the data is not being, the entries are not being displayed in any particular order. Let's say that I want to display all the customers in this table, and I want to order them by their first name. In order to do that, I go at the end of our statement, or on the next line if you want, but I'm going to go here. I'm going to type order by, and now I'm going to specify the column on which with which you're going to perform the order. So I'm going to type first underscore name and the optional semicolon. Let's put semicolon. Now let's run this. And now as you can see, they are sorted ascending by their first name. As you can see, we have A, and we have now we have the names starting with the B, and so on. And we have this store ID. Keep in mind this store ID, because we're going to use this with another example. But now let me show you that here you can type ascending order. But as I said, this is by default the order used if you don't specify any order. Now you may be wondering why you should type this if this is by default use. This can be helpful if, say, someone else comes to look at your code, and you'll see that you want specifically your order to be in ascending order, and you can specify descending order. So you type here descending, DSK. Now if you run this, as you can see, now it's starting from Z, and have W, V, T, and so on. So you can do this if you want. Now let's say that I want to have our customer being sorted by the store ID. What I can do, I can type here order by store ID. So store ID and the semicolon if you want, or you can delete that because it will still work. Let's run it. So now they are ordered by the store ID, but as you can see, we have you have so on, and if you keep scrolling, eventually you get to store ID 2. So we have here, we have store ID 2, as you can see now starting. Now they are sorted by the store ID, but the problem now is they are not sorted within the store ID. No, not within the store, within the store, because as you can see, you have multiple customers belonging to the same store. So I can do here, I can type order by store ID and also order by first underscore name, semicolon, if you want. So let's run this. Now I have one, and now they are also sorted within the store. So they are sorted first by the store ID and then by the first name. As you can see here, we have one, and we have A, and then B. So everything works fine. Let's keep scrolling, and we're gonna see the number 2 being shown, as you can see here now. So everything works fine. Now let's say that I want to get in our select statement only the store ID. So only the store ID, the first name, and the last name. Right? So let's run this. Let's push this on the next line. Let's push it only this. All right, let's run it. Now as you can see, we have the store ID, first name, and last name. So now we get in those columns that we specify in the select statement, and we get the data. We order it by the store ID and then by the first name. And we can specify here ascending, and here let's say descending if you want. So let's type with uppercase letters. Let's run it. And now they are sorted, as you can see here, first ascending. So the ID is ascending. So we have 1, then 2. As you can see here, let's scroll, we have 2. Now if I go back, as you can see, you have the first name sorted, and the sorted descending starting from this. So let's also type here also ascending. So let's run it. So now we have 1, Adam, and so on. So now everything is fine. One more thing that you can do is that if you don't specify in your select statement column, let's say, but I sort using that column, it will still work. So if you run this, as you can see, the store ID is not present in the select statement, but it's present here in the order by, and it's ordered by the store ID, and everything works fine. All right, this is our discussion about the order by, and see you in the next video. Welcome back. Now it's time to start a discussion about the limit command in PostgreSQL. So what is the limit command in PostgreSQL? The limit command in PostgreSQL is used to restrict the number of rows returned by a query. It allows you to specify a maximum number of rows to be included in the result set. This can be particularly useful when we have a large data set and only need to retrieve a subset of the data for analysis or display purposes. So this is what the limit command does. Now, here is how the limit command works. You have the select keyword, specify the column 1, column 2 from the table name, and you have limit and the number of rows. So you specify the number of rows that you want to have returned. So in this SQL query, we have the column 1, column 2. This the column you want to retrieve the data from. Next, we have the table name, the name of the table you want to query, and the number of rows and the maximum number of rows you want to retrieve. For example, if you have a table named employees and you want to retrieve the first 10 employees, you will use the following query. So you type select first name, last name from employees, limit 10. So this is gonna retrieve only the first 10 entries from the table. Now, the limit command is important for several reasons. First, we have performance optimization. When dealing with large data sets, fetching all rows can consume significant resources and slow down your database. Using limit allows you to fetch only the necessary amount of data, improving query performance. Second, we have pagination. In web application, you often need to display data in chunks, such as in pages. By combining limit with the offset clause, you can implement pagination easily. The offset specifies where to start fetching rows from. Resources. Next, we have resources management. So 3, by limiting the number of rows returned, you can reduce the memory and network resources required to process and transmit the query results. So these are the 3. Now, what is pagination? I also showed in the last video. I think I spoke about pagination, but I didn't say what it is. So pagination is a technique used in web application and databases to display and navigate through large sets of data in smaller, manageable chunks of pages. It involves breaking down a large data set into smaller subsets, typically with a fixed number of items per page, to improve user experience and performance. When you encounter a web page with a list of items, such as search results, blog posts, or products, you often see links or buttons at the bottom to navigate between pages of the list. This navigation is a form of pagination. Each page typically displays a subset of the total data, making it easier for users to browse to the content without being overwhelmed. So pagination basically means to fetch only a limited amount of data, and this can be useful. Let's say that you have a list and you want to display some data on that list. You will display, let's say, a specific item of a specific number of items in that list, and when the user reaches the bottom, you'll request to fetch some more data, and when it will reach again the bottom, you'll request to fetch some more data, and so on. So this in this way, you don't fetch the whole data at once. You get only chunks of data and we get the data when the user reaches the bottom of the list. So this is what pagination basically is. It's a very powerful thing, which is very used in programming. All right. Next. Now let's select everything from the payment table. So I'm going to type select everything from payment, semicolon. Let's run it. All right, and we have the payment ID, the customer ID, staff ID, rental amount, and payment date. Now let's say that I want to get everything from payment but ordered by the payment date. So I can type here select everything from payment, order by, and I can type here payment underscore date, and here we can specify ascending or descending. Let's let it ascending. Let's click on run, And now as you can see, we have everything ordered by the most recent payment date, by the payment date. Now, I can write this descending if I want, so I can retrieve this descending if I want. So now if I run this, now as you can see, we have 514, and previously, let me go back to ascending. It's lowercase letters, let's run. Now we have 214, so this is the month, and this is the date. This is what we can do. Now let's see how we can use the limit function. Let's say that I want to retrieve only the last 10 most recent payments. So in order to achieve that, I'll need to go here, and I can type here limit. You can type this on the same line or on the next line, limit, and let's put 10. And you can put an optional semicolon if you want. Now if you run this, now as you can see, we have our data, but we only have 10 entries now. So we have only the most recent 10 payments based on the payment date. Now let's say that as you can see here, let me check the amount, not the payment amount here. We have 0.99. Let's check. Let's put here another statement, and I'm gonna go up here, and before the order by, I'm gonna type where amount is not equal to 0. So now if you run this, we get our data, and now everything works fine. But now it will eliminate the ones which are equal to 0. In our case, actually, in our 10 results, there wasn't one which was equal to 0. Let's put amount is not equal to 0.99, let's say. So let's run it again, and we have here 0.99. Let's run it. And now if you look here, let me see, the 0.99 is not present, as you can see here. Right, I'm gonna end this video here, and see you in the next video. Welcome back. Now it's time to start a discussion about the built-in command in PostgreSQL. So what is the built-in command? The built-in command in PostgreSQL is used to filter data within a specified range of values. It is typically used in conjunction with the where clause to retrieve rows that fall within a specified range of values for a particular column. So first we have, here is a breakdown of its usage and significance. First we have the basic syntax of the built-in command is as follows. We have the select, the column, so we have the select statement, the column name or names from table name, where column name is, and I will use the built-in command value 1 and value 2. Next we have usage. So the built-in command is particularly useful when we want to filter rows based on a range of values for a specified column. For example, you might want to retrieve all orders made within a certain date range, or find employees whose salaries fall within a certain bracket. Inclusivity. One important aspect to note is that the built-in command is inclusive, meaning it includes both the specified start and end values in the range. For example, if you use between 10 and 20, it will include rows with values 10 and 20 and everything in between. So why use it? So why do you need to use the built-in command? The built-in command provides a concise way to filter data within a range, eliminating the need to write separate conditions for each boundary. It enhances the readability and maintainability of your SQL queries. Next we have performance. When using the built-in command, make sure that the column you're applying it has an appropriate index. Indexing the column can significantly improve query performance, as PostgreSQL can quickly narrow down the rows within the specified range. Examples. Retrieve orders within a specified date range. So you have select order ID, order date from orders, or order underscore date between 2023-0101 and 2023-0630. So next we have finding employees whose salaries between a certain range. So you have select employees ID, first name, last name, salary from employees, where salary is between 400 and 600. In summary, the built-in command in PostgreSQL is a powerful tool for filtering data within a specified range, making your queries more concise and readable. It is commonly used to retrieve rows that meet certain criteria without having to write multiple separate conditions. Now let's work on some examples in pgadmin. Therefore, I'm going to use the payment table. So I'm going to type select everything from the payment table. I'm going to limit only 5 entries. So let's run this. And we have 5 entries. We have payment ID, customer ID, staff ID, rental ID, amount, and payment date. And let's say that I want to select everything from payment where the amount is between $8 and $9. So I'm going to type between select from payment where amount, I'm going to type between 8 and 9, semicolon, the optional semicolon. If you want, you can now let's run this. As you can see, now we have all the payments, but the amount, as you can see here, is $8.99. So you have everything between 8 and 9. And if you want everything which is not between 8 and 9, you just put the not keyword here in front of between not. So now if you run this, you get $7.99. And if you want to see the now we get $7.99, $1.99, $7.99, $2.99. So we're selecting everything but not 8 and 9. So everything which is not 8 and 9. Now let's see how many transactions we have. Let's select here. Select count. Let's select all the transactions to see how many transactions between with the amount where the amount is between 8 and 9 are. So we have 439 transactions. So, and if you want to see which are not, put the not keyword here in uppercase letters, and we have, as you can see, we have a big number here, 14,157. Right. Let's say that I want to now to retrieve all the transactions from payment. Let's put back here from payment. Let's say let's run this to see how that table was called. So payment date, where the payment date, let's see all the transactions in the first half of January. In order to do that, I'm gonna go at the end of our statement, and I'll type here where, and I'll type payment date between, and I will put here single quotation marks 2007, now the month dash 01 and the day 01, and single quotation marks 2007 dash 01:15. Let's run this, and we get not many transactions. So let me change this to, let's say, first half of February. So let's change this to 02. Let's run. And as you can see, we have all the payments, but as you can see here, they are in the first half. As you can see, we have 2007, the amount is 02, and the date is 14, as you can see here. So now everything works fine. Previously, we didn't get anything because there is no transaction in January, but we have in February between day 1 and 15. All right, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the in command in PostgreSQL. So what is the in command in PostgreSQL? The in command in PostgreSQL is used to filter data based on a specified list of values for a particular column. It allows you to retrieve rows where a specified column's value matches any of the value in the given list. Here is a detailed explanation of the in command and its significance. So first we have the syntax. The basic syntax of the in command is as follows. You have the select, the column name or names from the table name, where, column, and we have the in command, and we put parentheses, value 1, value 2, and so on. So this is the syntax of the in command. Now at the Point 2, we have usage. The in command is particularly useful when you want to filter rows based on a list of values. It simplifies your query by allowing you to specify multiple acceptable values in a compact manner. This is especially handy when you have a long list of potential values to filter for. Next, we have 3, flexibility. The in command can be used with various data types, including numeric values, strings, and even subqueries. This flexibility makes it a versatile tool for querying data. And fourth, we have why use it. So there are a few key reasons why you might want to use the in command. First, we have reduced query complexity. When dealing with multiple possible values for a column, using in can simplify your query compared to writing separate OR conditions for each value. Improve readability. By using in, you make your SQL queries more concise and easier to read, especially when dealing with long lists of values. Efficiency. PostgreSQL's query optimizer can often optimize in queries more effectively than complex combinations of OR conditions. Alright, next. Now let's work on some examples in pgadmin. Therefore, I'm going to select everything from payment. And I'm going to type limit 5. Let's run this. And as you can see, we have here 5 entries, and we have payment ID, customer ID, staff ID, rental ID, amount, and payment date. Now, let's say that I want to get the distinct amounts which are in this table. In order to do that, I'm going to type here, select distinct amount from payment. Let's delete the limit. Let's run it. And now we have the distinct amounts which are in this table. We have 199, 1099, and so on. And now let's say that I want to get the amounts, only the amount. Let's say select everything from payment. So let's put asterisk before. And let's say that I want to get where amount parenthesis or amount in parenthesis, let's put 0.99, so the amount is in 0.99, and as you can see, this is colored in this specific color because it's a numeric value. Let's put 198 and 199. Let's put this in quotation marks actually. Alright, now let's run it. And as you can see, now you have all the amounts which are 199, 099, and 198, as you can see here. So now we have this using the in operator. Now, next, let's say that I want to get the amounts which is not in that in this list, so which is not 099, 198, and 199. So let's run this. Now you get all the entries which are not in this this list of entries. So as you can see, you have 799, 299, but you don't have 099, 199, or 98, or 199, as you can see here. Now let's give one more example with the where, but now I'm going to use the customer table. So I'm going to select everything from customer where first underscore name in parenthesis John, Jake, and Julie. Let's run this. As you can see, you have two customers, Julie and John. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the like and iLike commands in PostgreSQL. So what are the like and iLike commands in PostgreSQL? The like and iLike commands in PostgreSQL are used for pattern matching within text columns. They allow you to filter rows based on patterns defined using wildcard characters. The main difference between the two is that like performs case-sensitive matching, while iLike performs case-insensitive matching. Here is a detailed explanation of the like and iLike commands and their significance. So we have the syntax. And the basic syntax of the like command is, you have a query select from column name or names from table, where column name like and have the pattern, define the pattern. Next we have the basic syntax for the iLike command is, and the basic syntax for the iLike command is select from column name or names from table name, where column name is iLike and we define the pattern, so whatever pattern you are searching for. Now, we have wildcard characters, and wildcard characters are special characters used to represent one or more characters in a pattern. The percentage sign represents any sequence of characters, including 0 characters. The underscore represents a single character, and the square brackets represents a character class, allowing you to match any single character within the specified set. Next we have usage. And like and iLike are particularly useful when you want to search for values in a column that match a certain pattern. This is common when dealing with textual data such as names, addresses, or descriptions. They are especially handy when you want to perform partial searches, retrieve records that contain a specific substring, or filter data based on specific patterns. Next we have case sensitivity. Like performs case sensitive pattern matching. For example, if you use like apple percentage sign, it will match rows with the values apple shoes, but not apple with underscore a. So now let's look at the iLike, and iLike performs case insensitive pattern matching. It will match rows regardless of the case. For example, iLike apple would match apple shoes, and apple juice. Next, we have examples, and retrieving all customers with names starting with J. We have the following query for doing that. Select from customer name contact underscore email from customers, where customer name like, and we put single quotation marks J and percent sign. So it will retrieve all customers starting with the letter J. Next we have finding products with the names containing blue. We type select product name category from products, where product name like, and we have percent and sign. We have first single quotation mark, percent and sign, blue, and percent and sign. So this is for finding products. Next we have searching for employees with last name ending in son, case insensitive. So I have select for this particular example, we have select first name, last name from employees, where last name iLike, percentage sign, son. So that is going to return us the employees. Next we have wildcard characters. So wildcard characters are special symbols used in pattern matching within SQL queries. They are extremely useful for performing flexible searches and filtering based on specific patterns within text columns. Here is an explanation of the common with wildcard characters, their benefits, and when to use them. We have the percentage sign first, and the percentage sign represents any sequence of characters, including 0 characters. Use cases: searching for values that start with or end with a specific sequence of characters, finding records that contain a particular substring within a larger string. And we have an example. We have select product name from products, where product name like, we have single quotation marks, percentage sign apple, percentage sign, and single quotation mark. This query retrieves all products with the names containing the word apple. So this is very important to have in mind. Alright. Next we have underscore. And underscore represents a single character. Use cases: searching for values with a specific character at a certain position, you can do that, or finding records with a particular pattern where you know the character at a specific position. Example: you have select customer name from customers, where customer name like, and have single quotation mark J underscore, so you have the underscore wildcard, n, and you have percent sign and a closing single quotation mark. And this query retrieves customers with names that start with J and have any second character followed by n. So this is what this query is gonna do. Next we have square brackets. And square brackets represent a character class, allowing you to match any single character within the specified set. Searching for values that can have variations on specific character position, for example, if you for alternate spelling or formats. Example, we have select product underscore name from products, where product underscore name like, and we have single quotation marks, color, and we have the U in square brackets, R, and percent size and closing single quotation mark. And we have the same example, and this query that I presented will match products with the name starting with color and accounts for variation in spelling, such as color in British English. So this is what that is gonna do. Now, benefits of wildcard characters. Flexibility. Wildcards make your searches more flexible by allowing you to match a variety of patterns without specifying exact values. Next, we have efficiency. You can perform complex searches with a single query, eliminating the need for multiple separate queries. Reduce query complexity. Wildcards simplify query construction by enabling you to perform pattern-based filtering without writing lengthy conditional statements. Next, we have dynamic filtering. Wildcards are especially useful when you need to search for pattern within user-generated input or when the exact values are unknown. When to use wildcard characters. When you need to search for pattern within text data columns, when you want to perform partial searches or retrieve records that contain specific substrings, when you need to account for variations in spelling, formatting, or character positions, when constructing dynamic queries where the exact values are not known in advance. Now, let's see now how combining the percent signs, underscore, and square brackets allows you to create even more complex and specific pattern-based searches within SQL queries. This combination is particularly useful when you need to search for data with a specific structure or a pattern while accounting for variations. Here is an example how to use this combination along with use cases. We have syntax for combining wildcard characters. We have the percentage I, which represents any sequence of characters, including 0 characters. You have the underscore, which represents a single character. And we have square brackets, which represent character class, allowing you to match any single character within the specified set. Alright. And we have use cases, searching for email domains. Suppose you have a database table containing email addresses and you want to retrieve all email addresses from a specific domain, while allowing for variation in the domain name, such as different subdomains or top-level domains, TLD. Let's say you're interested in retrieving email addresses from both example.com and example.net. For that, you need to type the following query: select email underscore address from users where email underscore address like, and we have single quotation mark, percent sign, example, and we have square brackets, underscore, and we have dot, again square brackets, opening square brackets, left square bracket, you have CNO, right square bracket, and we have M. Now let's go next, and the explanation for this query. The percent sign example matches any email address that ends with example. The underscore square brackets inside square brackets matches any single character, which can be any character, including a dot in the email address. Dot, and we have square brackets, CNO, matches a single character from the character set CNO, which covers variations of the TLD, like C, N, or O, for .com, .net, .org. Results. This query would retrieve email addresses like user@example.com, admin@example.net, and any other variations that match the specified pattern. So this is what it's gonna do. Benefits and use cases. Versatile filtering. This combination of wildcard characters allows you to filter database on complex patterns with a higher level of flexibility. Next, we have pattern variations. You can capture variations in data such as different spelling formats or characters without writing separate conditions. Next, we have dynamic searches. This technique is valuable when dealing with user input or when you need to adapt queries to match evolving data patterns. Next, we have efficient querying. Instead of constructing multiple queries, you can achieve the desired filtering in a single query. And next, where to use. First, we have user-generated input. When users provide input that may have varying structure or pattern, example, names, addresses, phone numbers. Data cleanup, when you need to identify and correct inconsistencies in data formats. Domain filtering, as demonstrated in this example, when you search for specific domain variations in email addresses or URLs. And in summary, combining the percentage sign, underscore, and score brackets in SQL allows you to perform sophisticated pattern matching for specific use cases. This technique enhances your ability to filter and retrieve data while accommodating variations in patterns, making your queries more versatile and efficient. Now, let's work on some examples in pgadmin, and I'm going to use the customer table for this reason. So I'm going to type select everything from customer to see how it looks, semicolon. So let's run this. And we have the customer ID, store ID, first name, last name, email, address ID, active boolean, and so on. So let's say that I want to get all the customers whose name starts with the uppercase letter J. So I'm going to type here at the end of our statement, I'm going to delete the semicolon, and I will type where first underscore name, and I will type like, I will put single quotation marks, uppercase J, and I will put percentage sign. And now if you run this, now you get back all the persons whose first name starts with the letter J, as you can see here. And if you want to see how many people there are, you can scroll down, you're gonna see 65, or you can type here count, and if you run this, it will return 65. So there are 65 persons whose name starts with the uppercase letter J. And I can type here and let's say last underscore name, like, I'm gonna put like, single quotation marks, I'm gonna put S, percentage sign. So now if you run this, as you can see, you get 5 persons back whose first name starts with uppercase letter J and whose last name starts with the uppercase letter S, as you can see here. And this is case sensitive. If I put lowercase j here, and if I run this, now it will not return anything back, because now it's the like is case sensitive, so it will match the exact letter. So if it's an uppercase J, it will match only the uppercase J in the first name. So if you want to don't be case sensitive, you type here I like, and here's also I like. And now if you run this, as you can see, now you get back Julie, Jeffrey, Jonathan, Jace, and Jimmy, and now we have Sankez, Pierre, and so on. So this is let's put this on the next line. This is how we can use this. Now let's say that I want to get back let's say our first name, and let's put like with uppercase letters, like, and let's say that I want to get all the persons whose first name have in itself it has the ER present. So what can I do to achieve that? In order to achieve that, I'm gonna put single quotation marks. I'm gonna put, let's say, I'm gonna put percentage sign. So I'm gonna say, I'm gonna get all the characters which are before ER and which are after ER. So what this is gonna do is gonna return all the names which have in their characters which has in their name the present ER, E and R, and you will not care about what is before the ER and what is after the ER. So this is what you're saying here. So now if you run this, as you can see, you have Jennifer, you have Kimberly, Catherine. So all of those names have present in their construction, their first name, the letters E and R, and we don't care what is before and what is after. But if you want, let's say that before to be only one character, in order to do that, I'm going to put underscore, so the underscore operator. So now if you run this, it will only accept now a single letter before the E and R. So as you can see, you have Teresa, Berta, Veronica. So you have only one letter before the ER, and we don't care by putting the percent sign after the ER. We're saying that we don't care what is the number of characters which came before the ER. So you can put also here another underscore, and now we're gonna accept only a letter before the ER and a letter after the ER. So now if you run this, we get only this, because this is the only which has a letter before the ER and the letter after the ER. So you get only Vera, as you can see here. So this is how you can use the like and iLike. And you can also put here not like. So you can put not like. So now if you run this, it will get all the first names which don't have the ER present in their name, which don't have this construction specifically, a letter before the ER and letter after the ER. So you get, as you can see here, a lot of names which are matching this pattern. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to do some challenges with the knowledge that we have accumulated so far. And the first challenge is to retrieve the first name and last name and email from all customers. So this is the first challenge. And next I'm going to give you some hints. And the hints are to use the select statement to choose specific columns from the customer table. And now I'm going to show you the solution. The solution is to type select first name, last name, email from customer. Alright, now let's do the second challenge. The second challenge is called conditional retrieval. So challenge is to retrieve the payment ID, customer ID and amount from payments with an amount greater than 100. And I'm going to give you some hints now. Hints. Use the where clause to filter rows based on a condition. And now the solution. Solution is to select payment ID, customer ID, amount from payment where amount is greater than 100. So this is the solution. The next challenge, we have sorting and limiting, and the challenge is to retrieve the first name, last name and email of customers sorted by last name in ascending order and limit the results to 5. So this is the challenge. Now let's give you some hints. And the hints is to use the order by clause to sort the result and the limit clause to restrict the number of rows returned. Now the solution is to type select first name, last name, email from customer, order by last name, ascending, limit to 5. So this is the now challenge number 5. Data filtering. Challenge: retrieve the payment ID, customer ID, and payment date from payments made in the year 2022. I'm going to give you some hints. Use the, and this is something which exceeds what I taught you, and this is to use the extract function to extract specific components, like here from a date. And this is a aggregate function. I'm going to look at the aggregate functions in the next chapter, but I thought that's a good idea to give you a challenge with this. All right. Solution: select from payment, select payment ID, customer ID, payment date from payment where, and we have the extract function year from payment date equals to 2022. Next, challenge number 5 is called pattern matching, and the challenge is to retrieve the first name, last name and email of customers whose email contains the Gmail. I'm going to give you some hints now. Hints is to use the like operator along with the wildcards % and sign to perform pattern matching. Now I'm going to give you the solution, and the solution is select the first name, last name, email from customer where email, like and single quotation mark, %sign, Gmail, %sign and closing single quotation mark. So this is the solution. Now challenge number 6 is called range query, and here you need to retrieve the payment ID, customer ID and amount from payments with an amount between 50 and 100 inclusive. Hence, use the between operator to specify a range. And now the solution is to type select payment ID, customer ID, amount from payment, where amount is between 50 and 100. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about aggregate functions. So what are aggregate functions? In PostgreSQL, aggregate functions are special functions that perform calculations on a set of values and return a single value as a result. These functions are commonly used to summarize or derive meaningful insights from large datasets in a database. Instead of operating on individual rows, aggregate functions work on a group of rows and return a single value for each group. They are crucial for tasks such as calculating averages, sums, counts, minimum and maximum values, and more. Next, we have some key aspects of aggregate functions. And first, we have grouping rows. Aggregate functions are often used in conjunction with the group by clause that we're going to study in the next videos. And the group by clause divides the result set into groups based on one or more columns. The aggregate functions then operate on each group separately, producing a single result for each group. And second, we have common aggregate functions. And PostgreSQL provides a wide range of aggregate functions that carry to various analytical needs. Some of the most common aggregate functions include sum, which calculates the sum of a numeric column within a group; average, which computes the average of a numeric column within a group; count, which counts the number of rows within a group. We already used this. Mean, which returns the minimum value from a column. Mean, which returns the minimum value from a column within a group, and max, which returns the maximum value from a column within a group. Right. Now let's explore those functions in pgadmin, and I'm going to use the film table. So I'm going to type select everything from film semicolon. So let's run it, and we have film ID, title, description, and we have release here, language ID, rental, duration, rental rate, length, and the replacement cost. And let's say that I want to get the movie with the minimum replacement cost. Let's say that I want to see that. In order to do that, I'm going to delete this, and I will type select mean parentheses. Now I'm going to specify the table. No, I'm going to specify the columns. I'm going to type replacement cost from film. Now if you run this, we get 999. So this is the minimum value, and you can also get the maximum value. So I can delete this mean. I'm going to type here max replacement cost from film. Let's run it, and we get 29 and 99. So this is the maximum replacement cost for a movie. And what you can't do is to select another column here. So I can type here, let's say let's type rating. It will not work. So if you run this, get a problem. As you can see, film must appear in the group by clause. So we cannot select a table. You cannot select a column here, because this aggregate function returns only one value, and we only get that value back. And because I put here also select the rating from film, it will select all the ratings from film, and here we say that I want a value back, one single value. So in this because of this, we cannot have another column here. But what you can do is put a comma, and I can type here mean, and let's type replacement cost from film. So now if you run this, now this will work. We get 2099, the maximum value, and the minimum value 999, as you can see here. Now let's look at the average function. So let's delete this, and to get the average, I'm going to type avg, also for the replacement cost. Let's run it, and we get 90, and we get 0.984000, and we have a lot of decimal points. Now we can round this to only a specific amount of decimal points by putting round parentheses, and in this round we need to specify first the value that you want to round and the number of digits that you want the value to be rounded to. So I'm going to put here, let's say 3 closing parentheses, and now if you run this, we get 90 984. Alright, so this is how you can use the round, and you can also, let's say that I want to replace all the movies in my list, and I want to see what it will cost, how much it will cost me to replace all those movies. In order to do that, you need to use the sum function. So I'm gonna delete this. I'm gonna type sum, and it will sum replacement cost, and it will sum all the columns. So now if you run this, get 9,884, as you can see here. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the group by command in PostgreSQL. So what is the group by command in PostgreSQL, or more specifically, what is group by and why it's necessary? In SQL, the group by clause is used to group rows from a table based on one or more columns. This grouping enables the application of aggregate functions, such as sum, count, average, mean, and max, on subsets of data sharing common values in the specified columns. Essentially, it transforms individual rows into summarized information, aiding in the analysis of large datasets and revealing trends and insights that might not be immediately apparent. For the group by clause to be effective, it's essential to select categorical or discrete columns. These columns contain discrete values, often representing categories, classes, or labels. This distinction is crucial because aggregate functions are meaningful only when applied to categorical data, as attempting to aggregate continuous data could lead to nonsensical results. Now, the group by operation follows a split, apply, combine process. Let's consider a hypothetical sales table with the columns region, product, and sales amount. To analyze the total sales for each region, we apply the following steps. We split so first step is split, and the dataset is basically divided into groups based on unique values in the region column. The apply, aggregate functions such as sum, sales amount are applied to the sales amount column within region group. Combine. The aggregated results are combined, creating a summary table that displays the total sales for each region, as you will immediately see in this diagram. So, suppose we have the following sales table, and you have the region, the product, the sales amount, and you have the region north, south, and you have the product AA, B, and you have the sales amount, and you have 1,000, 50,000, 12,000, and 18,000. And by applying the group by region, we obtain north and south. And north, it has 22,000 and south is 32,000 because we apply sum on sales amount column. So now, this is how that will look. It will divide our and the categorical data here is the region, because we group by that one. Now, when and how to use group by, best practices and considerations. The group by clause serves various purposes and scenarios. It is particularly valuable when aggregating data to compute summary statistics such as total averages or counts for distinct categories within a dataset. Segmentation, to analyze data by discrete attributes, aiding in the identifying patterns and trends. Reporting, for generating summarized reports and dashboards, simplifying complex data for decision makers. When using group by, several considerations and warrant attention. Column selection. Choose categorical columns relevant to the analysis. Grouping by too many columns can lead to excessive complexity and information overload. Aggregate functions. Select appropriate aggregate functions based on insights you seek. Applying incorrect functions can distort the interpretation of results. Sorting. If necessary, specify sorting order using order by clause to arrange groups or results in a meaningful way. Filtering. Incorporate filtering criteria, often using the having clause. We're going to look at this in the next videos, to focus on specific data subsets within groups. Common pitfalls and mistakes to avoid. While group by is a powerful tool, mishandling it can lead to misleading or incorrect results. Here are some common mistakes to avoid. Missing columns. When selecting columns, ensure that they are either part of the group by clause or are being used with the appropriate aggregate functions. Overlooking nulls. Be mindful of null values, as they can affect grouping and aggregation results. Use functions like callsc to handle nulls appropriately. We're gonna look at this command in the next videos. Now, next we have misplaced where and having clauses. Place filtering criteria and the where clause to filter data before grouping. Use having clause, we're gonna look at this in a video, to filter aggregate results after grouping. Inconsistent aggregation. Be consistent with aggregate functions and grouping columns. Mixing levels of aggregation within the same query can lead to confusion. In conclusion, the group by command in PostgreSQL is an indispensable tool for analyzing and summarizing data. It transforms raw data into meaningful insights by applying aggregate functions to categorical columns, as you saw in that previous example. By understanding the split apply combine process and adhering to the best practices, users can harness the power of group by to uncover hidden patterns and trends within datasets. However, caution must be exercised to avoid common pitfalls that can compromise the accuracy and reliability of the results. With proper use, the group by clause can become an invaluable asset for any database analyst or data professional, enhancing their ability to distill complex data into actionable knowledge. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the group by statement in PostgreSQL. But first, let's explore the payment table to see what we have there. So I'm gonna type select everything from payment. Let's run this. And we have the payment ID, customer ID, staff ID, rental ID, and amount, and we have the payment date. So what we have here, and this customer ID is categorical. We're gonna use this to group in our group by statement to group our customers. Now, what we have here is the customer ID, the staff with which the customer interacted. So we have the customer ID, and it interacted with different staff's IDs, and it rented different movies. And later we're gonna see how we can join this rental ID to get the actual movie. And we have the amount spent on that renting, on that particular transaction. Now let's select the customer ID. So we're gonna run a simple query here. From payment, let's group by customer ID. And let's run this. And now I have the customer IDs, as you can see here. And this is the same thing as using the distinct statement, this distinct keyword. So what we have here is the customer ID, and this group by the also by the customer ID. Now, let's say that I want to see the amount, the total amount spent by each customer. So I want to see the total amount per customer ID. In order to do that, I'm going to put a comma here. I'll type sum. So I'm going to use the aggregate function. I'm going to sum the amount, group by customer ID. And let's run this to see what we get back. And now we get the total amount spent by each customer ID. So 184 spent, probably this is $80 and $80. And we have customer ID 87, we have this amount and so on. So now we're getting the total amount spent per customer ID. Now, let's say that that I want to order this. I can order by I can type here order by, and I can't type here simply order by amount, because this column that we have here, sum, is the sum amount. So it's the total sum amount. It's not simply a sum. So I need to use here order by sum and amount, because this is what this column is that we see here. So now if you run this, As you can see now, it is order ascending. We have 318, we have $27, so on. And here you can specify ascending or descending. So if you run this, you'll get the same output. And if I type descending, let's run it. Now you get which customers spend the most amount on renting. So this is ordering descending. Now let's say that I want to select multiple columns in our query. How I can do that? What I can do is I can type, let's delete this. Let's delete this. Let's select again from payment because I want to see the table again. So let's run it. And let's say that I want to get the customer ID. So I want to get the customer ID, the staff ID, and we're gonna aggregate sum amount from payment. I'm gonna type here group by, and we're gonna group by the customer ID, customer underscore ID, and by staff ID. And we're gonna order by sum amount. I'm gonna explain immediately what we have here, and here should be staff and a staff ID. So let's run this. Now what we have here is we have the sum, we have the staff ID and the customer ID. And how we will read this? You'll read this in the following way. We have the total amount spent with this staff ID by this customer ID. So we have this total amount spent by staff per staff ID and per customer ID. And as you can see here, we have another customer ID spent with this staff ID, and we have the amount. So again, we have the sum amount spent per staff ID. So with the amount spent with this particular staff ID by this customer ID. So this is what we have here. All right. Now let's say that let's delete this. And one more thing to point here is that you can change the order here. So I can put first staff ID and then customer ID. So staff underscore ID and then the customer ID. And this is not you're gonna have the same data display, but you're gonna have the same data, but it's gonna be displayed differently. You have the first staff ID and then the customer ID and the amount. So you can change this if you want. It will not affect the query staff ID. Now let's delete this. And let's export again the payment table. Let's run it. All right, and let's say that I want to, let me show you first a function, which is the date function, and I'm going to use the date function on this payment date that we have here. And I'm going to use that because I want to see the sum amount of transactions per each day. So in order to achieve that, you need to, but first, so I'm going to type here date, select date. I'm gonna type here payment date from payment. And I'm gonna type here group by. So group by date. I'm gonna use also payment date. And we use this payment, we use the date and the payment date. So you use this thing that we have here because this is a timestamp and I want to get only the day. So I want to get the year, the month and the day. I don't want to get the hour. So by using this date, you're gonna do that. And you can also order So I'm gonna type here order by, again by sum, and I'm gonna type amount. Let's run this, and we have, as you can see here, we have the date, and we have, if you, I think I can increase this. Let me see. No, I can't. Or let me check. Anyway, we have the year, the month, and the day, and let's also aggregate. So let's use the sum function here to get the total amounts. So I'm gonna type sum amount. So I'm gonna get the amount per each day. So get the total amount which was spent by each day. So if you run this now, as you can see, we have on this particular date, 2007-02-14, we have 116 and so on. So now we get the sum amount. So we get the sum amount per day. And again, we use date, payment date, in order to get the date in this particular format, which is the year, the month, and the day. So do not include the hour, because I don't want to see the total amount on each transaction per minute. I want to see them by the day. So this is why I use day here. And this is our discussion. One more thing that I forgot to show is that you can select the total sum amount. Let's type here customer ID. So just a second, customer ID, and instead of sum amount, I'm gonna use count. So count amount to see the total number of transactions per customer ID. So group by, and I will type here so I'm gonna type group by customer ID, order by, count amount. So notice that this now it's answering the question, what is the total amount of transactions and per each customer ID, and previously it was asking the question, what is the total amount per customer ID. So now if you run this, you're gonna get this in the output. So you see the customer ID 318 had 7 transactions, the customer 281 had 10, and so on. All right, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to do some challenges using the knowledge that we have so far. And the first challenge is to find the total amount collected by each staff member. This is the expected result, a list of staff IDs along with the total amount they have collected. Hint is considered using the group by clause and the aggregate functions like sum. And the solution is to type select staff ID column, sum amount from payment, group by staff ID. This is the solution to our first challenge. Our second challenge is to list all the payments made on a specific date. Expected result, a list of payments IDs, amounts, and payment dates for payment made on specified date. Hints, use the where clause to filter rows based on payment date. And this is the solution. Select payment ID, amount, payment date from payment, where payment date equals, and we have the year, month, and day. Alright, I'm gonna end this video here and see you in the next video. Welcome back. Now it's time to start a discussion about the having command in PostgreSQL. So what is the having command? The having command in PostgreSQL is used in conjunction with the group by clause to filter the results of a query based on the aggregated values of a column or columns. It allows you to apply conditions to the result set after grouping has been performed. In other words, while the where clause filters individual rows before they are grouped, the having clause filters groups of rows after they have been grouped. Here is a breakdown of its key aspects. First, we have purpose. The having clause is used to filter rows in the results set after grouping and aggregation, specifically when you want to filter groups based on aggregated values. Usage. It follows the group by clause and comes after the SQL query. The basic syntax is select the column name, the aggregate function on the column from the table, group by the column, and having at the end, having, and we put the condition. So next we have need for having. While the where clause filters individual rows before grouping, the having clause filters groups of rows based on the aggregated results. This is especially useful when you want to filter out groups that met certain criteria. Scenario to use. You should use having when you need to filter out groups on aggregate functions like count, sum, average, etc. For example, finding the average salary of departments with an average salary greater than a certain value. Next, we have comparison with where. Use where to filter individual rows before grouping and having to filter groups after aggregation. Avoid unnecessary complexity. While having is powerful, avoid overusing it or making it too complex. Sometimes it might be more efficient to use subqueries or other methods to achieve the desired result. And we're going to look at subqueries in the next chapter. Now, performance consideration. When using having, consider the performance impact, especially when dealing with large datasets. Improper use of having can lead to slower query execution times. Examples. Let's say that you want to find the departments with more than 10 employees. You type select department, count, and put asterisk from employees, group by department, having, we put having count greater than 10. And it will find all the departments with more than 10 employees. Now, let's say that you want to find the average salary of departments with an average salary above 5000. So let's say that you, in order to do that, you type select department, then use average salary from employees, group by department, having, and use the average salary greater than 50,000. And in summary, the having clause is used to filter group and aggregate result based on certain conditions. It is particularly helpful when you want to apply condition to the groups of data after they being grouped and aggregated using the group by clause. However, it's important to use it judiciously and consider its impact on query performance. Now let's explore the payment table to see how we can use the having command. So I'm going to type select. I'm going to select everything from payment. Let's run this. And you have the payment ID, customer ID, staff ID, rental ID, amount, and payment date. Now, let's say that I want to see the sum amount per customer ID. In order to do that, I'm going to type here select customer ID. I'm going to put comma, the aggregate function sum on amount from payment, group by customer ID. So this will return the amount per customer ID. So if you run this, we get 184 and it has 80, 87, we have 137. So now we get in the amount, so the total amount per customer ID. Now let's say that I want to filter this, or of course that I can put here a where clause or where command, and I can type here where, and I can type let's say customer underscore ID not in parentheses, let's put 184 to see that it will filter that out, and 87. And let's run this, and as you can see now 184 and 87 are skipped because we use this not in. But what if I want to filter the based on the sum amount? So I have the column sum amount here and I want to filter based on the sum amount column. How I can do that? I can type here select where customer and type sum amount. This seems okay, but if you run this, it will not work, and I will explain why. So we can't do this because this is this aggregate. This is a function which aggregates that column, and this sum amount. Let's actually I'm gonna keep this. This sum amount is called only when you call the group by. So in order to filter our grouped results, we need to add a having command after the group by, and it will filter the aggregated results. So if I go down here and I type having, and I will put here sum amount, let's put greater, it has to be a Boolean expression, so it has to be true or false, greater than 100. Now it will work, and we have the sum amount, and as you can see we have all the amounts here. Is the sum amount is greater than 100 because now it's filtering the aggregated results using this having. But again, you can't use the sum amount in the where, because the sum amount that is here, so this part here, is going to be called when the group by is reached. So when this command is reached, it will call sum amount and it will aggregate the results. All right. Now let's explore the customer table. So let's select everything from customer, and let's run it. And have the customer ID, store ID, first name, last name, email, address ID, active Boolean, create date, last update, active, so on. Now let's see that I want to see the total number of customers per store. How I can do that? In order to do that, I'm gonna go here. I'll type select from. I'm gonna type select store ID. I'm gonna put comma count. I'm gonna count the customer ID. So I'm gonna count the customer ID from customer. Group by store ID. We're gonna group by the store ID to get the total number of customer per store, and let's run it like this, and then I'm going to use the having. And as you can see, we have 326 and 273. So we're having the total number of customers per store. So store number 1 has 326 customers, and store number 2 has 273 customers. Now if I want to filter this aggregated result, what I can do is I can type here having, and I will type count customer ID, because that column is the count customer ID, it's not only customer ID. If I put customer ID here, greater, let's put than 300. You only have one greater than 300 as this one. So now if you run this, as you can see, we have 1 and 326, and you can also put here an asterisk, because this is actually saying here how many rows are per store ID. So you can put asterisk here and asterisk here, and it will work. So if you run this, you get the same result, but by using the customer ID here, I can see specifically that I am aggregating using the customer ID column. So let's put customer ID back. All right, I'm gonna end this video here and see you in the next video. Now it's time to start a discussion about the as statement in PostgreSQL. In PostgreSQL, you can think of the as statement as a tool that lets you give nicknames to tables, columns, or calculations within your queries. Just like how you might give your friends nicknames, you can give this element easier to remember names to make your queries less confusing. You'd want to use the as statement when, and we have first, you want to give friendlier names to columns in your query results. 2. You're dealing with math or complicated stuff and you want to simplify things by using a simpler name. 3. You're working with a table and its own copy, kind of like a twin, and you need to tell them apart. Here is how you would do it. You type select original name as new name from table name. Next, remember these 4 things. If you want to use spaces or special characters in your nickname, put the nickname in double quotes. Choose nicknames that make sense and are easy to understand. Don't go for really short or confusing nicknames. 3. Be consistent with your nicknames to keep things organized. 4. While nicknames don't usually slow down your query, don't go overboard with them in super complex queries. And finally, so the as statement is like giving your SQL elements friendly names, making your query less of a puzzle to solve. Now let's work on some examples to see how we can use the as operator. So I'm gonna type here select everything from payment to see how it looks. Payment, and I'm gonna run this. And we have the payment ID, customer ID, staff ID, rental ID, and amount. And let's say that I want to see the total number of transactions. In order to do that, I'm gonna use the count function. So I'm gonna type count. I'm gonna use the column amount. And if I run this, now we have the total number of transactions. But if you look at this for the first time, you will not see specifically what this is, because this is, as you can see here, is called count. So let's use the as operator to see how we can rename that to make it more clear what it is. So I'm going to type the as operator, and I'm going to type number transactions. So now if you run this, now we see specifically that this represents the number of transactions made. Now let's delete this. So let's delete this part, and let's select the customer ID. Gonna sum the amount to see how much each customer spent. Amount, and I'm gonna group by customer ID. So now if I run this, we see that we see the total amount which each customer spent. As you can see, the customer 184 spent 80, but we don't see specifically what this is, because this is simply called sum. So let's rename it, and to rename I'm going to use the as operator. So I'm going to type here as, and I'm going to call it total spent to see more specifically what that is. And we have now total spent here. So now we see specifically that this is the total spent, the total amount spent by each customer, as you can see here. Now we can use the having here. So I'm going to type here having, and I'll type here sum amount. Let's put greater than 100. So now we're going to get back only the sum amount which is greater than 100. So now if you run this, you can see we have only greater than 100. And one important thing to note is that the as operator gets executed at the end of a query, meaning that we cannot use the alias inside the where statement. So if so this is called total spent. Okay, so if let's say that I put here alright, so let's say that I put here instead of some amount, I'm gonna put here total spent. Now if I run this, we'll get an error which is column total spent. It says does not exist. So this is because the as operator gets executed at the end of the query, meaning that we cannot use it here. In order to use the having here, we need to use the sum and amount. So now if you run this, everything works fine. Alright, I'm gonna end this video here and see you in the next video.